Okay, for our next video, we are going to start with thrombocytes, or what are called platelets. If you're watching this, you might want to write this down. A normal platelet count is 250,000 to 500,000 per cubic millimeter per mm3. Once again, it depends on your reference. That was the reference our old textbook used, but that's a normal platelet count. Platelets come from this, that little hierarchy that I showed you with stem cells. It's a cool name. When platelets are forming, they actually at one point are these giant cells called a megakaryocyte, and then there's a part where it begins to break into little fragments, hence the broken plate thing, so they're called platelets, or thrombocytes. Throm means cartilage. Throm means clot. Excuse me. Yeah, the prefix throm refers to clot. Platelets help stick to damaged blood vessels, and they also release serotonin, which I know is a neurotransmitter, but serotonin causes squeezing of blood vessels. Now, hemostasis. Basically, blood will not clot unless you have platelets. They are very important. Any kind of disorder that involves a person not having many platelets in their system is bad because they cannot stop bleeding. I'm going to jump back over here now. So there's the megakaryocyte, and it kind of goes through a little bit of how these form. These do adhere to broken vessels if they're trying to cause a blood clot. And I didn't mean to go to that one. Those are megakaryocytes, and then yes, those little bitty dots in here, those little guys there are platelets or thrombocytes, and all these other things are red blood cells. And if I were in class, I'd ask you to identify these. Those are neutrophils. See all the multiple lobes on the nucleus. But hemostasis, stasis means stationary or refers to static, and hemos blood, so it's the process of blood clotting, which is actually really complicated. All right. So starting here, like I said, platelets, their sole function in life is to clot blood. I have a couple of pictures to show you. I'm going to start with this one first, and I'll go back. This here, now we are not going to be tested on this as far as detail, but you could spend an entire 4 weeks talking about the entire blood clotting mechanism on the cellular level, the biochemistry level. We're not in biochemistry, that's not our purpose, but see this little hierarchy here? It goes all the way down, and then at the very bottom, and I'm sorry about the font being so small, but it says a fibrin clot. This has to happen in a certain sequence or blood doesn't clot, and you have to have all of these factors. You see calcium, calcium ions. What's not on here is vitamin K. Vitamin K, you have to have that for blood clotting. And this happens to be the clotting mechanism for a broken vessel. There's a whole other mechanism for clots that form in arteries that are not broken. So here's tissue damage and all this. I'm going to summarize this for you. Here's tissue thromboplastin, which is one of the factors involved. So I'm going to go through your outline. I'm going to show you some of my drawings. Feel free to draw it if you want, and then I'll show you some actual pictures. Now, when you cut a blood vessel, in 3, 2, 1. Well, a lot of bleeding there. Probably wouldn't happen that way in real life, but let's say you cut a blood vessel. What ends up happening first is blood vessels will spasm shut. You have a picture for this. It's right there. It's sort of a natural reaction. There is smooth muscle in the walls of arteries and veins, and they will spasm shut. If you want a good drawing for that, feel free to draw this if you want to. Vessel, see the ends collapsing down. That's the first thing that happens with a damaged artery. Next, and what ends up happening is, and my writing hasn't improved even online, exposed collagen. There is collagen in the walls of an artery here. In fact, see how this is torn? Platelets will start sticking to the collagen, that tough protein, in the damaged area of the vessel. And so what ends up happening, and I drew a little platelet over here. Platelets have these ends that come off. They're like Velcro. And one platelet will stick to the collagen and one will stick down here. And then they'll just start piling up on top of themselves. That is called a platelet plug. If my drawing doesn't do it for you, maybe this one, although mine's much better. See, here's the collagen fibers. And then you see it's been damaged. And then you see here are the platelets. They started adhering. And at some point, yes, you get all the way to the end. Now, this is not a blood clot. A person would still be losing blood. Next thing in the sequence, platelets release serotonin, causes further constriction of the vessel along with the platelet plug. Once again, the whole purpose is trying to prevent blood loss. So here's the platelet plug area in your outline. Here's the vessel spasm we would be drawing, and then here's the release of serotonin. Now, this part. Nice little summary. Formation of a blood clot. So here's what would happen. So the little exposed ends, you have a damaged artery. And just like in class, I started out on the wrong note there. So this is damaged. This is vitamin K. This is calcium ions. All three of these together. If you have a damaged artery, vitamin K is already in blood. It's produced by bacteria in the colon. You get it from your diet. Calcium ions, they're also floating in plasma. Once an artery is severed, here, see it's cut. What happens is the damaged area releases something called tissue thromboplastin. That's actually on that little cascade of reactions that I showed you. That's a chemical. And what that does is the platelets that are all bound up in the end here, that causes platelets to release a chemical called Prothrombin Activator. It used to be called platelet factor. Now it's got a new name. So what does that do? Prothrombin is actually a plasma protein. It's produced by the liver. It's floating in plasma. It doesn't ever do anything. It's just waiting. When you have this little damaged area and these chemicals being released, and it all has to happen in this sequence, Prothrombin Activator converts prothrombin, a plasma protein. If you're wondering where'd that come from, it's already there. It's part of plasma. It's part of that stuff we were talking about earlier, that's the globulins and all the stuff that's in plasma. It's already there. Prothrombin Activator converts prothrombin into thrombin, which is now active. Proteins have to be activated. If thrombin was just released into your bloodstream, you'd have massive clotting everywhere. Because what happens is, once thrombin forms in the blood, thrombin converts fibrinogen. If you go back to the other video, remember fibrinogen is part of plasma. I said it was very important. It's a clotting factor. Fibrinogen is soluble. You can't see it. But in the presence of thrombin, fibrinogen converts into something called fibrin, which are little threads, and they're solid. And they start trapping red cells, and then you have what is called a fibrin clot. And then blood will stop flowing. That is the little cascade of reactions. And here is like a great picture. See the red cells and the yellow? Those are fibrin threads. See how it's catching everything? Now you have officially a blood clot. Couple of terms and okay, this is where that is in your outline. Feel free to look at this video and rewrite all of that. It's good studying for you. Okay, an abnormal intravascular clot. A thrombus, now these are clots that form when there's no damage. Thrombus is one that does not move. DVTs, deep vein thromboses. That's what a thrombus is. And that's just one example of one. An embolus is when a piece of this or maybe a smaller clot is movable and it starts going through the body. And those usually end up sticking in the lungs or the brain where the arterioles are very small. A pulmonary embolism, cerebral embolism. But that's an embolus. So, moving clot. Thrombus, stationary clot. Embolus, a moving clot. Okay, one more video. I'm going to start there real quickly and go through. We went through this in lab, but I'll start there with the next video.